Hi folks, we're going to take a look at this graphing example which is from page 340 and it's number 16. So first thing I want to notice here is that I'm working with a logarithmic function with base 10 and so I'm going to consider this as a transformation of y equals log base 10 of x. Okay. Now of course before I even start doing any work I notice that the input to the function is not in factored form, and I need it in factored form in order to correctly identify the horizontal transformation. So first thing I'm going to do is I'm going to factor out that negative a half in front of the x. Okay, and we're left with x, and so this is going to become minus, and 3 divided by 1/2 is 6. Okay, so very important, before you go anywhere, remember to factor any coefficient of the x variable. Okay, so now that I've done that, I can go ahead and interpret what the transformations are. Okay, and the way I'm going to graph this is by starting with 3 points on my parent function and then transform those 3 points based on the transformations shown in the function. Okay, so it's log base 10, so anytime we're working with a logarithmic function you definitely want to choose 1, 0. Okay, and now I'd like to choose 2 other nice points, and hopefully by now you see what we use as our method here is we want nice points as much as possible. So remember that the y value here would represent the exponent on the base, which is x, and x represents the result. Okay, so the next nice exponent after exponent 0 would be exponent 1. So 10 exponent 1 gives you 10. So the input is 10, and y value, which represents the exponent, is 1. Okay, then we'd like to get another point on the other side of 1, 0. So I'm going to pick an exponent of negative 1. Okay, so 10 to the negative 1, my result is x, 1 over 10. So my other point will be 1 over 10, negative 1. Okay. Now here, just as a little aside, hopefully we're seeing the pattern here. So always 1, 0. Then the next point will always be an input of whatever the base is, and the output will be 1. Next will be 1 over the base. In this case here, 1 over 10, and the output will be negative 1. Okay. So now we're going to find the transform points. So here y equals f at x is going to be our transformed function. Okay, so let's see what happens to these points, and from this point forward we're just dealing with the transformations themselves. So let's start with the horizontal transformations. We recall that it's always the opposite operation that we're performing on the x component, so multiplicative first. So the opposite of multiplying by negative a half is dividing by negative a half. But dividing by negative a half is the same as multiplying by 2. So multiply your x component by 2, and then you do your additive transformation. Again, the opposite, instead of subtracting 6, we're adding 6. Okay. Now for the y values, it's the same operation. So here we're multiplying our y component by negative a half, and then we're adding 2. Okay, so once I determine these operations, I just repeat them in the next 2 points. So multiplying the x component by negative 2, and then adding 6. Multiplying the y component by negative a half, adding 2. Okay, same thing here. Multiply by negative 2. Oops, this is 1 over 10, and then add 6. Here, multiply the y value by negative a half. This is negative 1 plus 2. Okay, and now let's figure out what these points are. So here we have negative 2 plus 6 is 4, and here we've got 0 plus 2 is 2. Okay, so there's my transform point. Okay, here we've got negative 20 plus 6. That'll be negative 14. And then here we have negative a half plus 2. So negative 0.5 plus 2 is just going to be 1.5. Okay, and now for the last one we have negative 2 over 10, which is negative 1 over 5. So negative 0.2 plus 6, so that's going to be 5.8. And here I've got positive a half plus 2, so that's just going to be 2.5. Okay, so these are now the transform points that we're going to use to sketch the graph. The other thing I'm going to use is the fact that this transform logarithmic function, since it retains the shape of the parent, is also going to have a vertical asymptote. Okay, now let's keep in mind what log base 10 looks like. Log base 10 has a vertical asymptote of x equals 0. In other words, the y-axis. And we know that the only transformations that affect anything on the y-axis will be our horizontal translations. So the only thing that's going to affect the asymptote is going to be our horizontal translation. Okay, so since the whole function is moving to the right by 6, so is the vertical asymptote. So x equals 6 will be our vertical asymptote. Okay, so now we'll sketch the graph. Now this one here has points that are a little further apart than we've seen. So here, if we look at the x values, we're going from a low of -14 and a high of 5.8. So certainly going up and down by 1, and in fact even going up and down by 2 won't fit on the graph. So I'm going to let each tick represent 3 units. Okay. And now let's figure out, and since it goes to -14, I'm going to place my x-axis a little further to the right. And for our y-axis, we see that the numbers are very, very close. Okay, so here, you know, I might go up by 0.2 or 0.5. So let's say we'll go up by, you know, I suppose 0.5. And since they're all positive, I'm going to put my x-axis a little lower. So let's put our x-axis, say here, and our y-axis, say we put it somewhere here. Okay, and we're going to go up by 3. And here, -3, -6, 9, -12, -15. Okay. And our x-axis, we said we were going to go up by 0.5. So 0.5, 1, 1.5, 2, 2.5, 3. Okay, and before I start plotting my points, I will put my vertical asymptote. So my vertical asymptote occurs at x equals 6. Okay, and now I'm going to plot my points. Okay, so we have 4, 2. So here, cut this into 3 portions. So 4 is around here, and we're going to 2. So there's 1 point. Okay. Then we have 5.8, which is very, very close to our asymptote. Okay, and we've got 2.5. So I'm going to do my best to sort of draw something very, very close to the asymptote without touching it. And then we've got our -14, which will be, if we cut this into 3 parts, somewhere here, and 1.5. So 1.5 and 14 will be somewhere there. Okay, so now we're going to try to carefully draw this. So we know that this keeps decreasing, and we know that it's going to approach the asymptote. Looks like it's going to approach it very sharply. Okay, so what I would do is try to sketch it out a little. And then once you've got a sketch, now you can draw it a little better. Okay, and again, we don't expect perfection, but we want to get something as nice as possible. Okay, so there we have it. So just a recap of what you're looking for. Anytime you get a function that looks like it should be viewed as the transformation of a simpler function, determine the parent, in this case here log base 10. Okay, before you move on, if the input is not factored, please make sure you factor it. And then once you've chosen your 3 representative points from your parent function, apply the transformations as they should be applied. Okay? Remember that anything that's horizontal will be the opposite operation. Anything that's vertical will be the same operation. Okay? Include any specific features that your function will have. In this case here, a vertical asymptote. Choose your scale correctly. Set up your structure. Plot your points. And draw the graph as the same shape as the parent function.